Okay, well here's a normal distribution. We're going to have to use the standard normal curve. Before we do, let's organise the information on a diagram. Always helpful with these sort of things. Normal distribution, bell-shaped. Centre line, the line of symmetry there, is the mean average, mu, and we don't know that, and that's the problem, I think. And sigma, we're told, is 5. We're also told that 70.5%, 0.705, remember probability always means in these questions area. The area, the probability, 0.705, less than 153. The problem with this question is that we don't know the mean, the mu here, and whenever we don't know those, we've got a problem. We can find points, we can find areas, but we need mu or sigma to do it. So if we don't know those, what we've always got to do is we've got to track back to what we call the standard normal curve. The reason we track back to a standard normal curve is we know always the average is 0 and the standard deviation is 1. And it's useful because what matches are the areas. So we can match the areas and then we can simply map any points across. So if you don't know mu or sigma, then over to the standard normal where you always do know, and then track back. Okay, so let's work out the points on this thing on the calculator here. Statistics, distributions, normal, and we've got calculate the height of the curve, probabilities, we don't need that. This one, given a point, will give us an area, and this one, given the area, will give us the points. We've got the area, we want the points, F3. The tail, well, left, right or centre, this is a left tail, the area and we've got our sigma, which is 1, and our mu, mean average, 0, standard normal, and let's calculate that. That tells me the point, 0.539. That's my point here. Good, I know everything about this. All I've got to do is map back, and this you need to remember. From the Z curve, typical letter for our standard normal, to the X, our any old curve, what we do is translate mu, takes us back to 0, and shrink, scale it with sigma. That maps us from Z values to X values or vice versa. Okay, put our numbers in. What we have, our Z value 0.539 matches our X value 153, providing we transform it, minus the mu we don't know, divided sigma we do, and if we rearrange this, what we will find is that mu equals 153 minus 5 multiplied by 0.539. I'll let you sort that bit out. And go to the calculator again. Key that in. $150.3, and that is our value of mu, that is our average mean height, centimetres. Okay, second part of the question. In fact, let me just get rid of these things. I'll shrink them down just in case we need them again. Second part of the question, probability taller than 156. Normal curve, I now know quite a bit about it. 150.3 is the average, standard deviation is 5, and I want to know probability, area, remember, of being taller than 156. I know a point, I want an area, I know these two things, I can just go to my calculator. Distributions, normal, and know a point, get an area, that's this NC cumulative one, lower, upper, just put in a big value, get yourself right along to the end there. Standard deviation, 5. Average, mean average, 150.3. Probability, 0.127. There's my answer. So my probability is 0.127, 12.7%, and I've done.